this v square is equal to what A of V.
Hello everyone, this is Sushant, and today we'll be discussing, not discussing, but we'll be taking an introduction to creating smart contracts on an Ethereum blockchain. So before we begin that, I would like to give you a brief introduction about blockchain. So what is a blockchain? A blockchain is a chain of blocks that contains some information and are connected from one end to another. The blockchain was introduced in 1991 before it was adapted by Satoshi Nakamoto to create Bitcoin. The Bitcoin we know, which striked a huge, which gained very huge media attention back in 2018. So blockchain is a distributed ledger. What do I mean by distributed ledger? A ledger that is distributed among all the persons in the blockchain. All right, so you probably can see me now. Let's start with again. So a blockchain is a chain of blocks containing some information and which is connected through one end to another. Blockchain was introduced in 1991 before being adapted by Satoshi Nakamoto in 2009 to create the Bitcoin, which gained a lot of attention back in 2018 because almost from the time of creation, it jumped to 2000% in value. So a blockchain is a distributed ledger. Distributed ledger. What do we mean by a distributed ledger? It's a P2P network where each and every one of the person joining the network gets a copy of the distributed ledger. So now, so manipulating a blockchain is very difficult because each of you has a copy. So if I decide to come in and suppose I decide to manipulate a block, so everyone has to verify that transaction before it is actually added to the blockchain. So that is all I'm going to cover about blockchain. Let's move on to smart contracts. So smart contracts did exist in the Bitcoin itself, but the use of it is very limited in Bitcoin. So Ethereum comes in and Ethereum introduces a new language, Solidity, which is just used to create smart contracts in Ethereum. So Ethereum provides a lot more support to create smart contracts over the blockchain. Now, what do I mean by the term smart contracts? Smart contracts are usually a piece of program that you can put over a blockchain. So if you can secure transactions over a blockchain, you can probably secure everything over blockchain. And that is what smart contracts intend to do. So smart contracts are really are immutable, as we know that, because every block in a blockchain is immutable and impossible to hack. So because every person has to verify the transaction over the P2P network. So before we begin, we also should know why Ethereum was introduced, because we already had a cryptocurrency called Bitcoin. So Ethereum was introduced to support smart contracts. So Ethereum also provided us with a language called Solidity. So Solidity is an object-oriented, high-level language for implementing smart contracts. It is influenced by JavaScript, as you can see, and it is used to write smart contracts. So Ethereum also provides us with a compiler that actually compiles the Solidity code that we write. So we have a compiler here. I've written some code. One second. Okay. So I've written some code. As you can see, Pragma Solidity 0. That's the latest version. And I've created a contract called point. I've taken a variable called point, initialized it to 0, and added some functions to actually add a point and subtract a point. Pretty easy, as you can see. So now what do I do is I download a blockchain, because to deploy smart contracts we need a blockchain. So there is a really good tool available on the internet. Goes by the name Ganache. You can find it out over trufflepayment.com/Ganache. You can download it for Windows and other OS as well. So I've downloaded it. Let me go through the installation procedure just very quickly. While it is installing, we'll also download the Ethereum wallet, because to privately work on a blockchain, we would also need a private wallet ourselves. So I'll download a copy of Ethereum wallet on my machine as well. I've also downloaded it as well. I'll just extract it to the same. As you can see, the Ganache is already set up and running. I'll open it, Ganache. And doing that, I would also open my Ethereum wallet. So when you open your extracted Ethereum wallet, you would see something like that. Now, I've already written the smart contract. Let's just look at the Ganache and its controls that it has provided us with. All right, I'll just hit continue. Okay, so it's as you can see, there's accounts, there are blocks. There's transaction, there's logs. So let us just load up automine the blocks. It would provide us with 10 default blocks for us to work with on our local host. So it would take a bit of time to load all the default boxes. While it's booting up, let's just, if you're using the Remix Solidity compiler, you would go into details, and we would need the bytecode of the program. So you'd find it here. Copy that. I can redo the process if you want me to. I'll go to details and I would copy the object key from the bytecode. Now, as you can see, I've got 10 blocks, 10 default blocks with their unique addresses and a demo balance. Now, I would go to my Ether wallet. You can cross that out. All right. So right now, my Ethereum wallet is connected to Ethereum.com, which is not that what we want. We want it to connect to our private blockchain and communicate with it, so that we can deploy and interact with our contracts. So I would go in to the bottom of the list. There is an option called Add Custom Network. So using this, we can connect our private blockchain that we have set up using Ganache and connect it to our Ethereum wallet. So I can name it whatever I want. Suppose I call it MyQ. Now I take the address of my blockchain, which is HTTP 127.1, and I will also need the code, which is 7545. As soon as I put in my custom node, it says you are successfully connected, which means my Ethereum wallet is now connected to my blockchain. Now, what do we have to do? We are looking at contracts. So we go into contracts. We will deploy the contract first. I hit on deploy contract. So the bytecode that I told you to copy is now needed here. Oh, sorry. Let's copy it again. So you want to copy the object key. And now we have the option, how would you like to access your wallet? So I would like to access my wallet using my private key. Now where do I get this private key? I get this using my blockchain and specifically a block. So I choose any of the block. Suppose I choose this one and I hit show keys. So I get a private key for my single block that I would like to work on the blockchain. I enter the private key and I unlock it. So you can see wallet successfully declared. Now I sign the transaction and deploy the contract. You are about to deploy a contract. It will be deployed on the following network. Ether, the ETH node you are sending through is custom. Here the custom is our own private blockchain that I saved using the name MyQ. So yes, I am sure to make this transaction. As you can see, my transaction has been broadcasted to the network. If I go here, you can see this transaction count was 0 and now it is 1. So I have actually made a transaction over my private blockchain. So if I go into transactions, I can see there is a transaction goes by the name contract creation. So my contract is actually created now. Now we actually want to interact with it. If I had to interact with contract, it asks me for a contract address, which I can get from here. Contract, created contract address, copy that, right? And we missed the alphabet. Okay, so it's taken the address. Now, what is this API JSON interface? It is actually provided to us by the compiler itself. So I head on over to the details section again, and I copy the API, copied value to clipboard, and I paste it over here, and I access the contract. So it has successfully connected to my contract now, and I can select the function. As you can see, the list of functions that I created in the contract itself are shown to me. So if I hit get points, it actually shows me a zero mount. Now, if I want to interact with my contract, I can just write a transaction at point. Now, in this, we don't need to send an amount because we are creating our own custom contract, which doesn't need actually an amount. So I can just generate a transaction right away. Yes, I'm sure make transaction, and you can see your transaction has been broadcast to the network. If we go back to our blockchain, the transaction count should have increased. Yes, it has increased. So this transaction has also been made to our blockchain. So you can see there's this contract call. So first transaction that we made was a contract creation because we created the actual contract over a blockchain, and the next one was the contract call to actually interact with it. Now if I go back in and use the subtract point method and write it, yes, generate transaction, yes, transaction has been published to the network, and I now get the points. It's zero because I incremented it once and decremented it once. And you can see as soon as I make the transaction, it is over here on my blockchain as well. Now, this was the most basic smart contract over Ethereum blockchain, but the actual smart contracts are not that easy and a little bit different. The premise is the same. You create the code, you deploy it over your blockchain, and then you just use it like a smart contract. So what actually do we use smart contracts for? What we can actually use for the smart contracts for? Well, any smart contract that exists right now on paper or which is easily manipulatable or easily anyone can come in and tamper with it can be put over the blockchain to make sure that that you cannot tamper with it, and it is conditional. So if I go ahead and take a loan from a bank company and make that transaction over a smart contract. So if I meet specific requirements, then only I would get the loan, or else I would not be getting any loan. And this was just a mere example for smart contracts. We can do with the possibilities to use smart contracts are limitless actually, and everyone gets a copy of the smart contract, so it is impossible to hack because everyone needs to verify any changes that are made in the smart contracts itself. So that's pretty much it for this session of blockchain smart contracts over Ethereum blockchain. Let's just do a recap of what we learned today. We learned how to deploy a private blockchain using Ganache over our local host. We learned how to create our own Ethereum wallet. Ethereum wallet because the Ethereum was actually introduced to support smart contracts in a better way than Bitcoin did because there was only limited options available with Bitcoin smart contracts. That's why Ethereum was introduced, and we got a hang of Solidity as well. We wrote some clean short code to deploy that on the blockchain in Solidity. You can learn more over the Solidity at solidity.redocs.io. And we learned how to actually deploy and interact with our contracts. Now, in the next session, we would probably connect our Ethereum wallet. We would learn how to actually communicate with people and transact among a number of people, rather than just having our own localhost wallet, we would create a wallet over the Ethereum network, because Ethereum does provide us with more network to work on and some demo money, not actual money. So we can do that in the next session. So that's pretty much it for today. Thank you.